Sound waves interfere in the same way that other waves do in space. Constructive interference occurs when two crests meet. You can see that in red. This means that when a listener is located where constructive interference is occurring, there will be a loud spot. Destructive interference occurs where a crest and a trough meet. You can see that in green. And when the listener is located where destructive interference is occurring, there will be little or no sound. Take a look at what constructive interference and destructive interference look like in this picture of waves on a ripple tank. You can see that the interference alternates between loud spots and spots of no sound. A constructive interference pattern is given by d sine theta equals m lambda, where d is the distance between two speakers, theta is the angular displacement, m is a multiple, and lambda is the wavelength. Tan theta equals x over L, and for small angles, sine theta equals tan theta, so x is equal to m lambda L over d, where L is equal to the distance from the speakers to the wall. M is called the order of interference fringe, and x is the location of the loud spot. Note that the approximation can only be used for small angles, so angles that are less than 10 degrees. The destructive interference pattern is similar to that of the constructive interference pattern. The only difference is that instead of m, we're using m plus a half, because remember that extra distance is equal to a multiple plus a wavelength, you get destructive interference. Again, this approximation can only be used for small angles.